Okay, so to start, here's the problem we're working with. We made our free body diagram last time, and I said I was going to project these onto an XY plane, and here we go. So, if this is our XY coordinate system, and these are our forces acting in each direction, we need a way to make sure that we can mathematically prove that these all add up to one number, right? And so the way we're going to do this is I'm going to say that if all the forces, all of them, are equal to 0, that means if I took these and I put their projection down on this, and I saw how much of them was acting in the x direction, all the forces acting in that x direction are going to equal 0. And all the forces, if I took these and I put them on the y-axis, all the forces acting in the y direction are going to be 0. You say, how do we get all these forces in just two directions? Because look, they're going in 1, 2, 3 different directions, right? So, to simplify these further, what we're going to do is I'm going to say I can draw a triangle, a right triangle, with my axis. We're going to start with T1. The same applies over here to T2. And I'm going to ignore MG for just a minute, because I think that it's painfully obvious that this is already acting in the y direction, the negative y direction, to be specific. Now, the trick then is going to be getting T1 and T2 into what we are going to call components of T1 and T2. And we'll see that we have two more triangles. Just like this. I won't need to show that. So, easier to see now? So, we know from our other problem that this is an angle theta from the horizontal. Okay? And now that we have this measurement, we can start seeing how to shape these two components. If you remember the trigonometry that we previously discussed, you'll see that if I define this length as the magnitude of the force T1 and this length as the magnitude of the force T2, we can define the x length and the y length respectively for each one of these. So what I'm going to do is I'm going to work exclusively with T1 for just a minute, and then the principles will apply to T2. If this is our triangle, and I'm just going to draw it in hopefully bold, if this is the triangle I'm trying to work with right here, and this is length T1, then I can define this side as T1 sine theta. And that's going to be the length from here to here. Okay? And then again, from here to here, ooh, I'm going to erase this, just the corner, you know what it means, is T1 cosine theta. Just like that. Okay, let me give you a better look at it. So when you're looking at it, we've just taken this one line that's in space, and we said, well, I can make a right triangle out of it where it intersects with the x and y axis. So as you can see, what we can do is we can take this and boop, 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 put it over here. All right, then the same principle is going to apply to T2, where I'm going to have this side of my triangle and this side of my triangle. And this side will be equal to T2 sine theta. And this side will be equal to T2 sine theta. Now that we've simplified both of these forces, what we're going to have to do is we're going to have to take these two sides and use them to create a vector sum of all the forces.